Need to analyze text sentiment, but don't want to hard-code rules or manage separate NLP libraries? You'll see how to create a FastMCP tool that delegates sentiment analysis to the client's own LLM using just a simple prompt and the ctx.sample method. We'll handle the raw LLM response, normalize the output, and return clean, structured results.
From FastMCP, import FastMCP. Context. MCP equals FastMCP. Sampling demo. At MCP, tool. Async def analyze sentiment text. SDR ctx, context, dict. Analyze the sentiment of text using the client's LLM. Prompt equals F. Analyze the sentiment of the following text as positive, negative, or neutral. Just output a single word, positive, negative, or neutral. Text to analyze, text. Hash request LLM analysis. Response equals await ctx, sample, prompt. Hash process the LLM's response. Sentiment equals response, text strip, lower. Hash map to standard sentiment values. If positive in sentiment. Sentiment equals positive. If negative in sentiment. Sentiment equals negative. LC. Sentiment equals neutral. Return text, text, sentiment, sentiment.
This demonstrates the LLM delegation pattern, where complex natural language tasks are offloaded to a language model while your code handles orchestration and post-processing. The core concept is treating the LLM as a specialized service. You provide structured input, receive raw text output, then normalize and validate it programmatically. What makes this distinctive is the clean separation between AI capabilities and deterministic business logic. The pattern works through a declarative interface where your tool defines the task requirements, while the context object manages the LLM interaction. The framework abstracts away provider specifics, letting you focus on prompt design and response handling. This creates a unidirectional flow. Your code shapes the request, the LLM generates possibilities, and your logic constrains the output to expected formats. This approach matters because it solves the last-mile problem of AI integration, bridging unstructured LLM output with structured systems. You get the benefits of AI reasoning without sacrificing reliability, as your code enforces constraints the LLM might miss. It's particularly valuable for sentiment analysis, classification, or any task where you need AI flexibility combined with programmatic consistency. The trade-off is increased prompt engineering effort, but the payoff is maintainable, auditable AI interactions. Let's break it down.
From FastMCP, import FastMCP. Context.
This imports FastMCP, the core class for creating AI-callable tools, and context for logging and progress reporting. Every FastMCP tool requires these to integrate with the framework's execution model.
MCP equals FastMCP. Sampling demo.
This initializes the FastMCP server instance named sampling demo, creating the core bridge between Python functions and AI tools. All at MCP. Tool decorated functions will register with this instance, making them callable by AI models through this named channel.
At MCP, tool. Async def analyze sentiment text. SDR ctx, context, dict. Analyze the sentiment of text using the client's LLM. Prompt equals F. Analyze the sentiment of the following text as positive, negative, or neutral. Just output a single word, positive, negative, or neutral.
This defines an AI-callable tool using FastMCP's decorator pattern. The @MCP tool decorator exposes this function to AI models, while the type hints and docstring automatically generate the tool's schema. The prompt uses strict formatting constraints to force consistent LLM output, eliminating ambiguous responses. This pattern prevents post-processing errors by restricting the LLM to single-word outputs that map directly to our sentiment categories.
Text to analyze. Text.
This injects the input text into the prompt template, creating a complete instruction for the LLM. The F-string ensures dynamic insertion while maintaining the structured format that guides the model's response to exactly one word.
Hash request LLM analysis. Response equals await ctx.sample prompt.
This triggers the actual LLM call using FastMCP's sampling endpoint. The ctx.sample method sends your prompt to the configured model and awaits the response, handling all the underlying async communication. The context object manages this interaction, ensuring proper request formatting, error handling, and progress tracking, all abstracted away from your tool logic.
Hash process the LLM's response. Sentiment equals response, text strip, lower.
This normalizes the LLM's raw response before processing. Strip removes any leading trailing whitespace or newlines, while lower converts the text to lowercase, ensuring consistent case handling for the sentiment check that follows. This preprocessing step defeats false negatives from extra spaces or inconsistent capitalization in the model's output.
If positive in sentiment. Sentiment equals positive.
This normalizes the LLM's response to a standard positive value. It handles cases where the model might return variations like very positive or mostly positive, ensuring consistent output for downstream processing.
Return text, text, sentiment, sentiment.
This returns a structured dictionary containing both the original text and its analyzed sentiment. The consistent output format ensures predictable results for downstream processing, whether by other tools or the calling AI system. This pattern of returning normalized data structures is essential for reliable tool composition in FastMCP workflows. FastMCP tool schema pattern. The FastMCP tool decorator automatically generates OpenAPI-compatible schemas from Python type hints, exposing your functions to AI clients with full parameter validation. Type annotations like SDR or context become API contracts, so ensure they match your intended client usage exactly. This pattern eliminates manual schema writing while maintaining strict type safety across the AI boundary.
The schema that appears in the documentation was never written, yet it enforces every rule.